Hi, welcome to the mathcenter.com. In this video, we're going to look at parts of a problem that appeared on the specimen paper 2020 further maths, the CIE board, further maths paper 4. Paper 4, the subject code is 9231/04. Specimen paper. You can look this question paper up on the CIE website. Before we look at the solution and talk about the question itself, please give this video a like and share as much as you can. Please follow me on Facebook and YouTube. For details of the courses that we run on the Math Center, for details of the courses that we run online, please visit the mathcenter.com. And this question, I have worked a full solution to this. It will be given as a link to this video. So you'll have all the details in case I leave out some details. Okay, so let's start. I repeat, what's written on the board is the bare minimum. You read the question and then you can follow my solution easily. Okay, now the question is, it deals with probability generating functions. It's not something that's been tested before in the A levels. It's something new in our syllabus. So probability generating function, very, very important thing. So I'm glad that it's finally made it to the syllabus. It's something to be used when in first year and second year of courses in statistics, actuarial science, and so on. Okay, great. So now let's start. I will speak slowly. Okay, I'll speak slowly. There are a few parts to this. Let me get through part A first. So we have a bag. It contains 3 red and 3 white balls. That's the story. 3 red and 3 white. So we have a total of 6 balls in the bag. So what happens is, there's this person A. I think her name was Aisha then. So A selects a ball from this bag at random. So it selects a ball at random, notes the color, and then returns it to the bag. So the experiment is this, you take a ball out from the bag randomly, and then you look at the color, and then you put it back. So you know that when you say that, it will remind you of something called with replacement. Never mind, let's continue. So then after that, you repeat the process twice. That means how many times are you doing it? In all 3, right? You first take one ball, you look at the color, put it back. Then you repeat twice. That means in total you're doing it how many times? 3 times. So what does this remind you of? Before I look at the random variable x, let's talk about the random variable. X is the number of balls, number of red balls. Okay, x is the number of red balls selected. I repeat, the random variable x represents the number of red balls selected. Okay, so now that we have talked about the experiment and the way it's done with replacement and so on, it should ring a bell. It's a binomial experiment. Okay, binomial experiment. Okay, before that, what does the question want us to do? It wants you to find the probability generating function, PGF, of x, gx of t. So let's write down the things that we know. So gx of t is the expected value of tx, where x is the random variable. So expectation, so when you do expectation, you need to write this thing down, okay, multiplied by its associated probabilities. Remember, the idea is from this, expected value of x is x px, correct? Expected value of x is x px. So you have a value of x and a probability. So that's what we need to do now. That's the first thing. The second thing is we know we're dealing with a binomial experiment, and we are picking out a red ball a success. So we have x is binomial. How many trials? 3. What's the probability of getting a red? 3 red out of 6, half. Good, right? So x is the number of red balls selected. So probability x equal to 0. Let me do 1 or 2 of this. X equal to 0 will be 3c 0, a half real, and we have gone half raised to the power of 3. You will have 1 over 8. Let me do one more. Probability x equals to 1 will be 3c1, a half, and a half squared, 3 over 8. So similarly, you can work out probability x equals to 2. Those of you who are good in binomial distribution will know the answer is also 3 over 8. And probability x equals to 3 is 3c3, a half 3, and a half 0. You will get 1 over 8. Okay, So you get all the probabilities. X can take values 0, 1, 2, 3, correct? Okay. So let's come back here. I think I'll continue writing here. Remember, we are looking for the probability generating function of x, yeah? Gx of t. So what's the first value of x? 0. So t to the power of 0 is 1. Okay, 1 times, what's the probability of x equal to 0? 1 over 8. Got it? Then we go to the next one. Next value of x is 1. T to the power of 1 is 1. Excuse me. T to the power of 1 is t. Yeah? T. What's the probability x equals to 1? Where is it? 3 over 8. Next value of x is 2. Then we have t to the power of 2. And what's the probability of x equal to 2? 3 over 8. And finally we have t to the power of 3. And the probability of x equal to 3 is 1 over 8. Therefore, the generating function, the PGF, probability generating function of x will be 1 over 8 plus 3 over 8t plus 3 over 8t squared plus 1 over 8t cubed. Let me check. 1 over 8 plus 3 over 8t plus 3 over 8t squared plus 1 over 8t cubed. And we're done with part A. Thank you very much for watching. I'll come back and do part B in a separate video. Please share as much as you can. Give me a like and follow me on Facebook and YouTube. Thank you very much.